Okay guys, today I'm going to show you how to balance redox reactions, and overall it's a pretty simple process as long as you follow all the correct steps, which I'm going to walk you through. So this is going to be our redox equation, and we're going to break it up and show you how to balance it. So the first thing that you need to do is assign charges to everything, and you're going to start by assigning the oxidation charges that you know. So we know that nitrogen has a -3 charge. So we have a -3. So then carbon is going to have a positive charge. That's going to leave us with a negative charge because our Cn- ion has a -1 charge. So that means our carbon must have a +2 charge because +2 plus -3 is -1. Then moving on, our oxygen is going to be -2, and because we have 4 of them, it's going to contribute a charge of -8 overall. So to have a -1 charge overall, our manganese must have a +7 charge. And over here, our oxygen is going to have a -2 charge, and our nitrogen is going to have a -3 charge. And since our ion has a -1 charge, our carbon must have a +4 charge because +4 -3 -2 is -1. Over here, our oxygen will have a -2 charge, and -2 times 2 is -4. And since this is neutral, our manganese must have a +4 charge. So now our first step is going to be writing what our oxidation half-reaction is. So something that gets oxidized, it's losing electrons, and since it's losing electrons, that means it's going to become more positive. So over here, our carbon had a +2 charge, and over here it has a +4 charge, so it's becoming more positive by 2, so that must be our oxidation. So I'm going to go ahead and write that. And now we will write our reduction half-reaction. And that will be one about the type, and our manganese is being used because over here it had a +7 charge, and over here it only had a +4 charge. So now our next step is to balance our half-reactions, and we're going to balance everything except for the oxygens and hydrogens if you have any in your problem. However, here, our carbons, we only have 1 of each, 1 and 1, and our manganese is 1 and 1, so they're already balanced, so we're going to leave that be. And our next step is going to be balancing our oxygens. And you balance oxygens by adding H2O. So in our oxidation half-reaction, we have an oxygen on one side. So to balance that, we're going to have to add a water to the left side. So that is going to give us this, which I'm going to type here. Okay, and now we're going to balance our reduction half-reaction. And we have 2 more oxygens on this side. To balance it, we're going to add 2 waters to the other side. Okay, now our next step is to balance the hydrogens on each side, and to balance them, we're going to have to add a H plus ion. And that's going to be step 3. So we have 2 hydrogens here. Means we're going to have to add 2 hydrogens on this side. And now we have 4 hydrogens here. So we're going to have to add 4 over here. And now our next step is going to be to balance the charges on each side by adding electrons. So here our H2O is neutral and our CN is -1. And over here we have an overall charge of +1. So to get this side, the right side, down to -1, we're going to have to add 2 electrons. So that's now balanced. So now we're going to have to balance this half reaction. And the right side is neutral. There are no charges. And over here, we have a charge of +3. We have a +4 from the hydrogens. And we have a -1. And +4 minus 1 is +3. So we're going to have to add 3 electrons to make this side neutral. And now we're going to have to cancel out electrons. So we're going to have to multiply each equation. Up top we have 2 electrons, and on the bottom we have 3 electrons. So the least common factor is going to be 6. So I'm going to multiply the top reaction by 3, the bottom reaction by 2, and that's going to cancel out the electrons. That's going to be step 5. So now I'm going to multiply everything by 3, but I'm not going to write out the electrons because they're going to cancel. So up top we're going to have 6, and on the bottom we're going to have 6. Okay, and now we're going to start canceling out what we have left. So here we have 3 waters, and here we have 4 waters. So these 3 waters here, they're going to go away, and we're just going to have 1 water left here. And same thing with our hydrogen plus ions. We have 6 here and 8 here, which is going to leave us with 2 on the left side. So now we're going to combine our equation. Okay, so that's going to be our combined equation. Try and get this all on the screen for you. Okay, and that's our combined equation if it's in an acidic environment, but if it takes place in a basic environment, you're going to have to add an OH minus for every hydrogen plus ion that you have. So we're going to go ahead and do that, and you add them, and you add the OH minus ion to both sides, and then that's going to combine to give you water with your hydrogen plus ions. So if I add 2 OH minuses to this side, that's going to result in 2 H2O, which is going to give us 1 excess H2O on this side, because this one's going to then cancel out. And then we're going to have 2 OH minuses left on this side. So I'm going to write the final equation. Okay, and that gives us our final balanced equation for this reaction. And if you just follow these steps of balancing redox reactions, it's going to be very simple. And remember the last step of adding the OH minus ions to make water molecules. That is only for reactions that take place in a basic solution. And if you have any questions on what I did in the video, feel free to leave a comment below and I'll get back to you. And I hope this was helpful.